Okay, so floor plan is a drawing of the layout and dimensions of rooms. And so this is a floor plan. And so from this floor plan, we can learn that it's a one-bedroom apartment. That's our one bedroom right here. Because it doesn't have a closet? That is true. That is true. You're right. It doesn't have a, because here's the bathroom. You're right. It technically, if it does not have a built-in closet, it is technically not a bedroom. But we'll just go with a bedroom in this one. Okay. We have a kitchen. We have a living room. We have a dining area, otherwise known as the walk-in closet for the bedroom. Just kidding. We have a one bathroom. Okay, so those are the main rooms. Now this one didn't say bathroom, but there's a bathtub and a toilet and a sink, so we're just going to go ahead and assume that that is in fact a bathroom. Plus it's got tile. Okay, the bedroom is 15 by 12 feet. Okay. It has two windows. This is a window, and this is a window here. It has one door, and it has no closet. For whatever reason. Okay, the living room is 20 by 12 feet. It has a slider. So this is a sliding door. One entrance. And then it has like a little sort of two sort of exits into the bedroom dining area, but they're not doors. So two walkways. Okay. A door will always have this loopy thing on it. So there's a door, here's a door, here's a door. The sliding glass door looks like a double window, but they always have one that's bolded. So like the window is like the light gray, and then the sliding glass door will have a light gray and a dark black. Okay. The dining area is 8 foot by 7 feet, and it enters into the bedroom, living room, and kitchen. And the bathroom is kind of off of that as well. It has no windows. One, two, three, four. Most likely there's another unit right here and right here. Yeah, it would probably be going, I don't know exactly how, but like the layout would, because there's no windows along this wall, makes me think that there's something built here and here. So yeah, they do weird things. And I don't know why there's no window here or here, because this is a door, so that's obviously outside, but you know, whatever. The kitchen, here's the fridge right here. Has a fridge. sink. Well, it's a double sink. You can see that there, double sink. And a stove, a window, one entrance, and no door. This is what you'd call a galley kitchen. It's skinny and you like walk into it, that's called a galley kitchen. And then finally the bathroom has one door, and it has a tub, a sink, a toilet, and tile floors. Now, the major thing wrong I see with this apartment is there's not a closet in the whole place. There's no pantry, there's no closet. Now these are cabinets here, here, and here. Fridge. Yeah. So there's cabinets, but there's no linen closet, there's no bedroom closet, there's no storage of any kind in this apartment whatsoever. Even if it was cheap, you don't want it. Where would you put your stuff? Alright, so Jerry is using the floor plans for his new home to help him purchase base molding for the place where the wall meets the floor. Okay, base molding is also known as baseboards. Yeah, crowns on the ceiling. Yeah, crown because the top. Base molding is on the bottom. It's also known as baseboards, or as I like to call it, dust catchers. Okay, so the plans are drawn using a scale of 1/4 inch represents 1 foot. So we have 1/4 inch equals 1 foot. I lost my toolbox. Okay, he measures the walls on the floor plan, with a ruler, and find that they're 23.5 inches total. Okay, if molding is $2.10 per foot, how much is he going to spend? Okay. Here's our key information. 1 foot is equal to 1/4 of an inch. So every 1 inch would equal, come on, you guys can do this. 4 feet. If 1/4 of an inch is 1 foot, then 4 of them makes 1 inch, so 4 feet. Okay, so we have 23.5 inches total. If you don't like fractions, oops, put the decimal in the wrong place. If you don't like fractions, make it a decimal. I have 23.5 inches. Each inch is going to be 4 feet. So I'm going to take that 23.5 and I'm going to multiply it by 4. And I'm going to have 94 feet. Okay, so that's, as he went around, he measured not the actual wall, but on the floor plan he measured the squares, you know, so he went around the wall like this and measured all that. So that's going to be 94 feet around the whole outsides of the rooms. And it's $2.10 per foot, so I'm going to take 94 feet and I'm going to multiply that by $2.10 per foot. And it's going to cost him $197.40, not including nails. All right, so Gabriella wants to carpet. This is all going to be carpet, except for her piano. Actually, it's not a bad idea because you shouldn't put piano on carpet. Oh, well, yeah, that's a terrible idea, but okay. So the radius of the quarter circle, so this is an actual quarter circle. The radius is 8 feet. And we want to figure out how much will the carpet cost and it's $9.95 per square foot. So what we have is we have a rectangle minus a quarter circle. So far okay? We have a 25 by 16 foot radius or rectangle. So remember, the area is length times width of a rectangle. So 16 times 25 is, I think, 400. Yep, 400. So the total living room is 400 square feet. Oh, now we need to cut out that little quarter circle. Okay, and you guys remember area of a circle is pi r squared. And our radius is 8. So I get 3.14 times 64. So 200.96 is the whole circle. Now it's really important, that's the whole circle. We have a quarter circle. So we're going to take that 200.96 and we're going to divide it by 4. Or you can multiply it by 1/4, yeah. Same answer. 50.24 square feet is the quarter circle. So the area that needs to be carpeted is 400 minus 50.24. So 349.76 square feet. We're going to multiply that times the $9.95 price. So this particular expensive carpet is going to cost her $3,480.11. To find the area of a regular octagon or hexagon or pentagon or nonagon, basically a regular polyhedron of 5 sides or more, you use the same formula. Area is equal to 1/2 AP. A is the apothem, and P is the perimeter. Okay, and an apothem is sort of similar to a radius, except in a radius, anywhere you move along a circle, it'll always be the same length. The apothem goes from the center. So let me do this. Apothem is the line from the center perpendicular to a side. So this is 90 degrees right there. So it's like kind of like a radius to the side, but it has to be 90 degrees exactly to be the right distance. So if you drew it like even just a little bit further over here, it would not be the apothem anymore. Okay. And here's why this works, just in case you cared. Hold on, let me draw this like all kinds of pretty and stuff. Every polygon, 3 sides or more, which a polygon has to have 3 sides, is made up of triangles. So every square and rectangle is 2 triangles. 4 sides, 2 triangles. 5 sides has 3 triangles. So it's always like 2 less triangles. Here we have 8 sides. Actually, we're going to have 8 triangles, aren't we? 1, 2, 3, 4, 5, 6, 7. Yeah, 8 triangles. Okay, did I miss something? Anyway, in a regular polygon, the triangles are all the same size. A regular polygon is that all of the sides are the same length. Okay? So all the triangles are the same size, and now the area of a triangle is 1/2 base times height. Well, if you add up all the bases, you get the perimeter. And the heights are the same for everything. So you can do 1/2 the apothem, which is the height of the triangle, times the perimeter, and you get all of the areas of all of the triangles added together at once. That's how that works, in case you cared. Base. So to find the area of any regular polygon, I would first need to know the apothem and the perimeter. Well, I know that this base, or this part, is 10 feet, so this is 10, 10, 10, 10, 10, 10, 10. 1, 2, 3, 4, 5, 6, 7, 8. So the perimeter is equal to 8 times 10, which is 80. And they gave us the apothem. They said that's 12 times 80. 1/2 of 12 is 6 times 80 is 480 square feet. Now, they need to purchase wood for the floor of the gazebo, and it costs $14 a square foot for this special kind of outdoor pressure-treated whatever wood, right? So I'm going to take this area, and I'm going to multiply it by $14. And I'm going to get $6,720 to replace the floor, or to create the floor for this gazebo. Alright, so basically this is a free-form figure. Now you can accurately calculate the area of a free-form figure using calculus. Like non-regular shapes, that's why calculus was kind of invented, was to find the areas and volumes of irregular things. We're not going to do that. This is called the Monte Carlo method. This is basically an extremely accurate guess. And by extremely accurate, I mean it's really darn close, but it's probably not exact. Okay. Now what you do is you use probability. Okay. And there's, did I put on, no, okay, yeah. So here's what will happen. So you go to your computer, okay, and you map the thing out. So this would be done on the computer, where you take the picture of the garden and into scale, and you put it on a computer, and you see that it's a 15-foot by 20-foot rectangle that this would fit into, so, or 15 yards. So here's 15 yards, and here's 20 yards. Okay. Now what will happen then is the computer places random dots. Okay, so the computer places random dots all over the surface of this picture. So there's just, dots. We're not going to put all the dots in, but the computer puts lots of dots all over the surface of the picture. Okay? And what happens is, in this case, we're going to do 1,000 dots. Okay? So in this 15 by 20 grid, we're going to place 1,000 dots. 1,000 dots, he finds that 631 land on the garden. Okay? So out of the 1,000 randomly placed dots, 631 of them fall on the garden. So, the Monte Carlo method uses this formula. It's the number of dots inside the region divided by the number of total dots. Your book calls it points, dots, points, whatever. And you set that equal to the area of the region divided by the area of the grid. So we have 631 dots inside the region over 1,000 total dots. We don't know the area of the region. That's our unknown, so we're going to call it X. And the area of the grid, the rectangle, is 15 times 20. So that's going to give us 631 over 1,000 is equal to X over 3,000 or 300? 3,000. 300. What we now have is a proportion. So we cross multiply. And we're going to get 1,000x is equal to 631 times 300. So 1,000x is equal to 189,300. Divide both sides by 1,000. .3 square feet. So the garden is approximately 189.3 square feet. Can you do this without a computer? Sure. It's not as accurate because you're doing the dots, which means you're just sitting there going la 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 la, and you have to count up to 1,000, or you need a decent number of dots. So you'd be on the paper just random dots. You have to be really random. And then you have to count how many dots are in the figure. It's not as accurate, but will still give you enough of an estimate to be able to plan how much supplies you need, how much mulch, how much fertilizer, how many plants to cover the area. It's not perfect, but it's a good enough estimation tool for non-mathematicians. Yeah, you just dot. Yeah, just all over the place, and then you have to count how many dots in the garden versus outside the garden. Or not versus outside the garden, versus total. Yeah. But the computer does it better because it generates truly random dots. People can't be truly random. Because while you're doing this and you're doing the dots, you'll not want to hit the same dot again. And if you do hit the same dot again, how do you know it's one or two dots, right? So people will tend to try to fix it, whereas the computer will place them randomly, and some dots may land on top of each other, but the computer can keep track of how many that was. So that's why it's more accurate. We can't be completely, truly random. Does that make sense? So this is the formula that you would use, and it's based on probabilities. And like I said, it's not, basically it's the idea is that the ratio landing inside the area and the ratio landing outside the area should be about the same if it's truly random. So that should give you the right area. Nobody wants to learn the calculus version, right? Rectangle, volume is easy. Length times width times height. Okay, the volume of a room that is 14 by 16 by 8. So the volume is 14 times 16 times 8. Do that real quick here in my head. But instead of square feet, it's cubic feet. So it's going to be cubic. So if it's feet, it'll be cubed. If it's inches, it'll be cubed, etc. Okay. Now, why would you need to know the volume of a room? Okay. When you're purchasing heating and air, especially air conditioning, you get something called a BTU rating. Okay. And BTU stands for British Thermal Units. Okay. And the air conditioner that you purchase, okay, has a BTU rating. Now, if you buy an air conditioning unit for the volume of your house, let's say, that the BTU is too low compared to the volume of your house, it's going to overtax the system. It won't keep your house cool enough. You'll have crazy and high energy bills because it'll be running all the time, and it's going to burn out really fast. If you get a BTU rating that's too high for your house, because it's got a high BTU rating, it's using more energy to cool. It's probably going to make your house a little too cold, but it's going to be using more energy than you would actually need, so it's going to cost more. Now, it's not going to burn out faster, but it's sort of like just sort of throwing money away. You don't need that much consumption of energy. So you want to buy an air conditioning system that has the correct number of BTUs for your home. That's why this is important, and that's based off the volume of your house. Because, you know, you guys have heard this where people with like high voltage ceilings, their energies, yeah, because you have more air to have to cool. If you have low ceilings, there's not as much volume of air to be heating and cooling. If you have high ceilings, you have more volume of air. It's more expensive. Yeah. So the BTU rating, okay, is, okay, so let me, yes, exactly. They're very aesthetically pleasing, and you feel like big open space, but you're also heating and cooling a big open space. So, you know, now, okay, BTU rating is while divided by 60. While is being multiplied, W times H times I times L times E. W is the width of the room. H is the height of the room. Okay, L is the length of the room. So here you have the W, the H, and the L are giving you the volume. I is due with insulation. Okay, if the insulation is good, it's 10. If the insulation is bad, it's 18. Yeah. Insulation can have a huge impact on your home and its efficiency, like a huge impact. And they have an R rating. So if you guys go to Home Depot now and go look down the insulation aisle at the different kinds of insulations, they have an R rating on them. The higher the R number, the better the insulation is.
And when you say insulation, is
That's, yeah, you don't really want to use that, but inside the attic is usually like a foam, like a loose, cottony type thing, or the rolls. And then inside the wall is either the rolls usually or a spray foam that like expands
Right.
and fills up. Now the spray foam that expands and fills up the space is actually, generally speaking, the best insulation because it's filling up the space. There's no air in there, and so you're getting a good
Seal.
barrier. Yeah, so that's usually the.
Is that cheap
No,
at all?
no,
Do you have to sell your soul for it? Or
no. But it's not. Just finish this one. Okay, and then E is the direction the room faces. Okay, so you look at each room separately, kind of, and the exposure of the wall. So this is the exposed wall. So like in this room that we're in right now, the wall with the windows right there, that's the exposed wall, which is facing southish, I think. That's south, right? Huh? The exposed wall. So like which side of the house is it on? So is it on the east side, the west side, the north side, or the south side? So the wall that's not connected to the rest of the one that's like to the outside. Does that make more sense? Okay. Okay, so now if it's facing north, E is equal to 16. If it faces east, E is 17. If it faces south, E is 18, and if it faces west, E is 20. Okay. That's the way the wall faces.
How did they come up with these numbers?
That's a good question. I'm not exactly sure. The British did it a long time ago. Okay, so the bedroom is 16 by 14 and has a 9-foot ceiling. So this is your width and your length and your height. So we want to find out the BTU rating, and we've got while over 60. Now W we can say is 16. My height is 9. My I, it's well insulated. Well insulated tells me that I equals 10. And it's on the west side of the house, so E is equal to 20. And I forgot the length. Sorry, that should have been over here after the I. This is L. I put L in the wrong place. Not that it matters because it's multiplication. Okay, so I'm going to do 16 times 9 times 10 times 20 times 14. Yeah, I mean, it doesn't really matter because the multiplication doesn't matter. It's just to remember what to multiply is the word while. And then you divide by 60, and you get 6720 BTUs for that room.